Okay, so the problem with this question is that you don't know what the hypotenuse is. You don't know what this is. But it's a right triangle, so you need to recall from geometry that we have Pythagorean's theorem gives us this relationship between the two legs of a right triangle and the hypotenuse of a right triangle, where the sum of the squares of the two legs is equivalent to the square of the hypotenuse. So we use that to figure out what FG is, because if we don't find out what FG is, okay, we can't find the other trig functions. We just can't find the other ones. So we can't find sine, cosine, cosecant, secant. We can find tangent and we can find cotangent without the hypotenuse, but without that we're in trouble. So we need to adapt and we need to substitute those in. So if we make 24a becomes 24 squared plus 32, if we make that b, 32 squared equals c squared. When you square those and add those, you get 1600 equals c squared. And then you get the value of c to be technically plus or minus 40, but we're talking about lengths of sides of a triangle, so the negative value is extraneous, is irrelevant. Okay, so then we have this being 40, and we can go through and we can figure out the remaining sets. Okay, so if you then want to line them up, sine of g, cosine of g, tangent of g, cosecant of g, secant of g, and cotangent of g. Those are the 6 trig functions. A reminder, you're going to have to memorize those. You're going to have to memorize an annoying amount this chapter, just so you know. Sine was opposite over hypotenuse. We're talking about sine of g, so we're talking about this angle right here. The opposite is 24. The hypotenuse is 40. But that reduces to 3/5. Is that right? 3/5. So the sine of g is 3/5. Cosine of g is the adjacent, which is 32 over the hypotenuse, 40. 32 over 40 reduces to 4/5. Tangent of g is opposite over adjacent, so it's 24 over 32, which then reduces to 3 over 4. Right? Any questions on getting those? Those are straight geometry stuff. You've already done that. Okay? Next, the reciprocal trig functions, which are the new stuff from this chapter. That's just the reciprocal of that. So you could go back and you could say, okay, it's the hypotenuse over the opposite for cosecant, or if you already found sine, you just invert it. Or you just reciprocate it, sorry. At 5/3. And then to find secant would be 5/4. And cotangent would be 4/3. Anybody have any questions on that? Yep. Okay, the second part of this question, we're going to use the same triangle to answer this question. You did this one straight away in geometry as well. This is just a review. Find all the angle measures of triangle FHG. Which one do we know? We know H. H being 90, correct? Do we know what F is? No. Do we know what G is? No. Okay. Any ideas, any thoughts, any questions, any ideas on how to do it? When we're talking about this triangle and we want to find an angle, we can write a relationship between that angle and its sides using one of the trig functions. Correct? That's what we define them as. They're a relationship between the angles and the sides of the triangles. So we can write those same trig functions using the information we have when we're trying to find what f is, the measure of an angle f, or the measure of an angle g. Okay? To do that, we need to pick one of the trig functions that is applicable to the angle we're talking about. Let's actually start by finding g, because we have already kind of highlighted it over here. What trig function do you want to use to relate this angle g with the sides that we were given originally? The problem is sine and cosine both use the hypotenuse, which was an answer that we found when we were solving the problem in a different way. It's not part of the original information. By default, when you do any of these problems, if you're doing calculations, I want you to use the original information given, if you can. Okay? So if you remember from geometry, that should have been the same policy in geometry. I want you to use the opposite, the value for the opposite in relationship to g, and the value for the adjacent in relationship to g. Okay? By default. So which trig function deals with the original information, the opposite and the adjacent in terms of g? What? Tangent of g equals opposite over adjacent, correct? We know that. Or we said tangent was 3/4, and I'm just going to write 3/4. It doesn't matter. Okay, it doesn't matter. Now we need to solve this equation for g. Okay, so in order to get g out of the argument of tangent, we need to do the inverse function. Okay, we need to do the inverse operation of tangent. And to do that, that's kind of a calculator problem. So we do tan inverse on both sides of the equation, and those two then are inverse operations so that they reduce, and we're left with just g. Does that make sense? So then on the right side, we're just with tan inverse of 3/4 is going to give us the measure for g. Okay? So let's do that in your calculator. Grab your calculator and type it in. Second tan inverse 3/4 and hit enter. Make sure everybody does this. So you need to be pretty specific on that, whether it's in degrees or radians, so you have to give me the little circle to define that it's in degrees. Okay? To find f, we really should go back to the original information, okay, and use cotangent of f using, or no, we can use tangent, can't we? 32 over 24. So let's go back and we're going to do tangent of f is going to equal 32 over 24, opposite over adjacent. And then we do the inverse tan of that. Which then gives f equals inverse tan of 32 over 24. And we get what that is. .13 degrees. Okay? Degrees and radians conversation. All right, let's go to the next question. Here's a question again. I'm setting it up for you. I'm giving you some of the information, but not all. I want you to start applying the information using the models that I gave you, using the ratios that compare sides to angles, and I want you to answer the questions. Okay? So go back to the ratios, go back to what you know about those ratios, and start finding out information you need to find out. Okay, similar to how we did it last chapter. Okay, you should really start by drawing some right triangle, and you pick an angle to make A for fun, whatever you want, and then label things accordingly. Hopefully that's where you're at. Tangent of A, hopefully you got to the point that you remember that tangent is the opposite over the adjacent. So the opposite of A is 5, and the adjacent of A is 3. Find the value of cosecant of A. Well, cosecant of A, that's the reciprocal of sine. So that's the hypotenuse over the opposite. So the problem is then we don't have our hypotenuse, so you're stuck until you find what the hypotenuse is. The hypotenuse, Pythagorean theorem, right? You get square root 34, and that radical does not reduce, so we leave it as such. So we get square root 34 over the opposite, which was 5. So that is our answer for the first part. Okay? We can use that to get our sine of A, correct? It's the inverse of that, right? And not the inverse, but the reciprocal of that. So it's 5 over the square root 34, but we have an issue with writing it like that, don't we? Can't leave the radical in the denominator, so we have to rationalize it. So we have to multiply numerator and denominator by the square root of 34. So we get sine of A is then equal to 5 square root 34 over 5. Or over 34, rather. Sorry. There's our sine. Okay, we can keep getting the other ones. We could go down. We could get cosine if we wanted of A. We can do cosine of A as the adjacent over the hypotenuse, or 3 over square root 34, which reduced is 3 square root 34 over 34, right? 34 is not divisible by 3, so it doesn't reduce anymore. So that's our answer. So then we can get tangent. We already have tangent of A, which was 5/3. After we have cosine, it's a little easier to get secant of A, which is the reciprocal of that, square root 34 over 3, right? And cotangent of then A is 3/5. Yes?